Today, we have two presenters, namely Robert Stegwee. He's currently leading Work Package 1 in Unicom. He's also, for a couple of years, the chair of CEN-TC 251 for medical informatics. He is engaged in the HL7 community also for very, very long. Extremely knowledgeable about the domain we are going to address this afternoon. And the second speaker is José Costa Teixeira. José is active, among else, in IHE pharmacy in Europe, well, IHE pharmacy short. He's also very engaged in HL7, and he's also, to finish with that, part of the Work Package 1 team, extended team. So they both were the main author of the documents which they are going to present and comment for you. We selected a panelist for you, and I put the ladies first and the gentlemen later. So let me explain shortly who is who. Christine Hirtz is an ISO TC215 Working Group 6 member, and she will be co-leading the ISO efforts to develop this ISO IDMP logical model. Pardon me, I jumped over this charming lady in the middle, and Lise Stevens is the second Working Group 6 member who started to lead the development of the ISO IDMP logical model. Unfortunately, Lise is going to change her job and leave us, and she will be replaced by another colleague who volunteered yesterday to take over that co-leadership. In the middle, Julie James. I have to be polite. She's a very young person in this domain, although she said that she has 20 years practice. She is one of the first architects of the IDMP standards. So she has a very in-depth knowledge on the standards, and she is also very deeply involved in Unicom in another work package addressing, for example, adverse events. But she will certainly explain us later how that interacts with her specialties and views. Then I go to Giorgio Cangioli. Giorgio is part of the HL7 community as well. He's engaged in HL7 in Europe. He is also one of the Unicom Work Package 1 extended team. And he, in that function, also contributed to the development of these documents we are going to talk about. Then we have two gentlemen, Noel Diamant, who is working with the Austrian NCA, National Competent Authority. He was one of the reviewer of the documents which has been published already on the Unicom website as a draft, and he expressed himself with some, I would say, doubt about the appropriateness of this work. And the next is Jeff Martin, who is also working for an NCA, but this time in Sweden. And in the context of that consultation, the review, internal review, he was expressing himself in favor of that job. Although their opinion may have evolved in the meantime, we will discover that along the debate after the presentations. I hope it was not too long. I hope it did not make mistakes in these presentations, and if so, I ask for indulgence. Now I'm going to hand over to Robert and José, who are going to walk us through this topic. Robert?
Yes, thank you very much. And thank you for your kind introduction. We'll talk about the deliverable that has been published as a draft version on our website and has been distributed to you or made available to you. We will not follow the structure of the document section by section because that would be very boring. But in the next slide, I'll explain what our purpose for this community of expertise, our objective is really to explore how we can work together and how the future logical model can help you in your own work. And there's just a few notes that I'd like to make on this whole thing. I mean, Unicom cannot produce an ISO standard. So what we've done in the document is really look at the requirements for such a logical model. The need for an IDMP logical model was identified in ISO, and it's being worked on, as Christian mentioned, by Christine and Lise, or the replacement for Lise in the upcoming months. There's no definite timeline yet, but it probably will be over the next 2 years that this whole process will take place, including the ballots and the final publication. Also, we'd like to mention the gap analysis that we developed previously, and we discussed, I think in October it was, during a community of expertise, and the gap analysis already showed the need for more detailed logical models in a number of areas. So there, and we'll get back to those in a short time. But this is really something that's important to notice, that in the gaps, we already said, well, in order to really make things work with the implementation of IDMP, we need to understand the logical models for some of these more detailed areas as well. So next, I'll give you an overview of what we're going to talk about. I'll cover the landscape of IDMP and the need for a logical model, and really to foster a common understanding of what that is, that IDMP logical model. And then José will go into more details on the requirements and how we want to enable the use of IDMP logical model within your daily practice. And then we'll wrap up and we'll have the Q&A. So that's the agenda for today. If we go to the next slide, we can go to the landscape. We've been struggling really with what is it that we want to achieve from a standards point of view across the whole of Unicom and across the field of medicinal products. And we started out with looking at 3 application fields. You can also call them high-level processes if you want to. On the marketing authorization side, that's where a lot of focus has been, to get authorization to market your medicinal product, and also to do the post-marketing surveillance and the pharmacotherapeutic surveillance. So this is really at the population level, whether the population is a country or a region or the whole of Europe or the whole of the world. It's really at a population level, so at a health system level, if you want to. That's where processes take place that look at the big picture. And then another process is, of course, how to use that medication for an individual patient. So how do we support the effective clinical use of these medicinal products in day-to-day healthcare? And so that's on the personal point of view, at the individual point of view. And of course, there's also the physical product that we need to take care of. And that's where the supply chain comes in, including things like the Falsified Medicines Directive and other ways of really controlling that supply chain so that nothing goes wrong. So those are the 3 application fields that we've identified. And of course, everyone plays a role. And on the next slide, we can see that there's 5 types of organizations or implementation domains, if you will, that are engaged in these high-level processes. Development and production, that's fairly easy. That's the pharma business. Then, of course, the regulation and authorization and some related high-level organizations that are taking place or play a role in, especially the health system level. Of course, we need to kind of change the information that's available and make it available to the individual doctors and the individual patients. And how do we do that? There's organizations in place that play a crucial role in making all that information available to the individual physician through technology, of course. And then we go to the prescription and dispensation part. That's really where the individual doctor and the individual patient meet each other, and of course they go to the pharmacy to get their prescription filled. But the end result is really what counts. Does someone get better? What's the utilization? What's the outcome of the use of the medicinal product? And that, of course, needs to feed back through the whole process back. Sometimes even back to the pharma industry or the individual manufacturer of the medicinal product. So this is really helping us to understand what is it that we're talking about. In modeling terms, you would say, well, what's the universe of discourse, as was displayed on the previous slide? What is it that we're talking about? These are kind of the high-level processes and the roles that the different organizations play within these high-level processes or implementation domains where these standards need to be implemented in the systems of the individual organizations. So if we take a next step, we actually look at the crossroads. Because the crossroads of the role of the organization in the high-level process and how they detail their process within their organization, within their systems, that's where the real discussion needs to take place. Where do I use the IDMP standard definitions? Where do I use the data elements that are prescribed or in a normative way by the IDMP set of standards? So that's the combination of perspectives of the high-level processes, the application domain, fields, and the implementation domains. And that's where all the questions come from. And if you look at that from in a further step, we go to the actual identifiers. There are different classes of identifiers that are being used in those domains, depending on what is your objective. And of course, all the standards organizations working together try to support the use of clear identifiers and their supporting data elements in order to make sure that we're all on the same page, that we're talking the same language, that we're actually pointing to the same thing in our universe of discourse. So there will be national identification of medicinal products and packages. That's where the market authorization comes in. That needs to be identified at a national level. On a supply chain level, you look at a global unique identification of a package. Whether it's a GS1 barcode or anything else, that's what you're looking at. But from a different point of view, you would be looking at the INN, the International Non-Proprietary Names, because that's a more generic identifier for a medicinal product, so that it's easier to understand in terms of substitution, whether you can substitute one medicinal product for another or not. So that's the different types of things. And if you look at the pharmacotherapeutic drug class identifiers, that's much more for the pharmacovigilance and the overall use outcomes and uses data that's being collected at the population level. So the different objectives, the different uses require different types of identifiers that need to be correlated. And they need to be implemented across these 5 implementation domains and are part of one or more of these overall high-level processes or application fields. So that's the whole picture on the right, where you see how it all trickles down through the crossroads to the identifiers. So if we move on, then of course our question is, what does it mean that we have these crossroads, and we have these logical models at each of these crossroads? E-prescription already mentioned, patient summary. So there will be detailed logical models at all these intersections between the process and the organization that plays a role in that process. And our key question then becomes, how do we make sure that IDMP is coherently implemented across all these use cases? In all these, say, I mean, in the overall picture that you could identify 15 different crossroads, but if you really look at it, e-prescription and e-dispensing are 2 different processes. So there might be even 2 different models there as well, even though it's the same point at the crossroads of the implementation domain and the application fields. So how do we make sure that it's really done in the right way and in a similar, in a coherent way, so that the information can be used throughout the whole landscape? That's our key concern, and that's where the IDMP logical model comes in. It really seeks to link all those elements that are in common between the individual case-based logical models and say, well, this is where the coherence comes from across the whole landscape. This is what you need to look at. This is how it works together. And that also means that every detailed model can and should link into the elements of the logical model. So that you know, well, this is the use of the IDMP within our system, or this is the use of IDMP within the whole chain of ICSR reporting. So that's really what we're striving for with an IDMP logical model. But basically, one of the things that we really struggled with and we're working on in our team within Work Package 1 is well, if that's the role of a logical model, how do we specify the requirements? And a first impression is hopefully on the next slide, where we say, well, what is it? Actually, it is a data model. It's a logical data model because it's not bound to a specific process. It's kind of the base data model, reference model for all the data elements that are necessary to be exchanged wherever you are in the landscape. The common data elements, I mean, for different use cases, it will be much more detailed than at the IDMP logical model level. But so it is a data model, and it doesn't only describe the data elements, it also should describe the data types for these elements. And data types we really struggled with, because this is not your computer science data type. It's a string or a Boolean or an integer. No, it also should prescribe the reference terminology whenever applicable. If there is, for instance, around dose forms, there is a reference terminology for other things as well. So we really want to have the rich data types, not just the computer science interpretation, but a good description of what are the value sets that are to be used for this data element. And of course, there needs to be the cardinality and of the relations between the data elements or the groups of data elements. How are they linked together? And of course, there shall be a relation between a logical model and the business processes it serves. The IDMP logical model does not have specific business processes it serves, but in the essence, given the fact that the IDMP logical model is kind of overarching the detailed logical data models, those logical models need to link to the business processes. And of course, as mentioned in the slide and in the graphic that I showed just now, there needs to be a link. So there needs to be the possibility to map your own logical model or your specific business process specific logical model to the IDMP logical model. So that linkage, that mapping is really an important thing. So it's the glue between the more detailed logical models. If we want to have one model for everything, that would be far too ambitious and probably not even achievable. But it's kind of the glue. What are the common elements that we need to take care of from an overarching point of view for the whole of the landscape, and how do the individual detailed logical models link into that so that you achieve a coherent implementation of IDMP across those intersections in the landscape. I've spent a lot of time on a logical model. Of course, there's a relationship with a conceptual model. What does it mean? What does it refer to in the real world? That's usually just the concepts and the relationships with a good definition and a reference to what it does in the real world. The logical model then is, how do we model this? And if we go into much more detail in terms of the data elements, in terms of the groups, relationships, cardinality, data types, as I just mentioned. It says here string. The patient ID can be a string. I'm not sure whether that's the right thing, but on a global level, there is no global patient ID. So we don't have at an IDMP level, we don't have a given value set that the patient ID will come from. But there could be something else mentioned there as well. One of the reasons that that ISO Working Group 6 decided to move towards a logical model for IDMP or a new logical model for IDMP is that some of the implementation details were driven or were detailed in the technical specifications that accompany the 5 standards. The SPL, the Structured Product Labeling standard, is an HL7v3 standard that included some of the details that actually shouldn't have been there and should have been part of the logical model. So we want to have a technology independent description and a full description at a technology independent level of all the data elements that make up the IDMP logical model. So whatever is currently in the physical level in the technical specification, which is usually linked to a specific implementation technology, like HL7 version 3 or HL7 Fire or Edifact or anything else that people do. So that's where we're coming from. So the logical model really needs a very detailed description, but technology independent. So we go to the next slide, please. Really, the logical model needs to have a link with the conceptual model. It's out of scope for us because we were tasked with developing the requirements for a logical model, but one of the requirements is that there should be a conceptual model. Of course, it doesn't mean that we have to wait until we have a full conceptual model of the IDMP universe of discourse, but it should be noted that we should reference the same glossary of terms. I mean, if there's a concept out there and the logical model details a concept in terms of what are the data elements and the cardinalities of the relationships of this concept with something else, then it needs to reference the right elements of the conceptual model. And as I said earlier, it shall be independent of any technology. So that's where we are. I'd like to make one step into this linkage, because that's key in our model, that we have these detailed models that link into the IDMP logical model. And linking is not an easy thing. We describe it a little bit in our document, but it's also highlighted on the next slide. Linking items across models is really, I mean, it's easy if it's identical. I mean, if you say, well, this is an identical item, but sometimes it's semantically equivalent items. I mean, they're called differently, but they refer to the same thing in the real world at the same level of granularity. And that level of granularity comes in when you talk about generically or partitively related terms. It can be just a level higher or a level lower, and that makes it hard. Associated terms, we don't know what the association is, but there is an association. And you can even go into mapped items that, yes, there is a mapping, but whether it's generic, partitively, semantically equivalent, that depends on the map. So linking is not just an easy task. Linking is not something yet that can be done automatically by someone. You really need to have an understanding of what you're talking about to do this. And we already have some mappings, of course. We have the concept mappings across the different logical models. We know where the MP ID, the PHP ID, or the package product ID is being used. So we do have at least a partial insight in where the links are, but it's not complete. And there might be differences in interpretation, so we need to check some of those links. It's not just the data element level, but also the terminologies that are related to the data types that can be mapped or can be linked, like the SNOMED to MEDRA map that's necessary to actually report back to the competent authorities in terms of MEDRA, even though you have your records in, you may have your records in your electronic health record system in SNOMED CT. Of course, before you map terminologies, you need to make sure that there is an actual conceptual agreement between the data elements that you're trying to use this map for, because otherwise it doesn't make sense. And finally, in terms of linking and mapping, there needs to be a process to manage this. If something changes, what does it mean for the map or for the links that you've provided, either in the standards, in the models, or in the terminologies that you employ? How do you manage that? So thinking we'll have a mapping and that's done. No, having a mapping means also additional maintenance processes, additional work to be done by the experts to actually make sure that that the things that you have mapped will stay true and safe in the future as well. So these are just some ideas and some first ideas on the requirements for an IDMP logical model. So I'd like to go back to the illustration that I showed you to really go back to understanding what this is about. We have this full landscape, and across the landscape, we like to make sure that whenever necessary, we talk about the same identifiers, we talk about the same identifying data elements and the relationships they have with each other. So we try to model those in an IDMP logical model, and whenever someone comes in and says, well, this is my part of the puzzle and I'm going to solve this, that's where you can map to your IDMP logical model. And if we look into how you could actually use this logical model to be in real life, that's on the next slide. Please realize that we don't have a fully specified and formalized ISO IDMP logical model yet, but major parts are already there in the standards, so you can use them. And of course, there will be a back and forth between the people using this IDMP logical model and the people specifying it. That's where working group 6 comes in. If you really look at how to use it, just identify the data elements in your logical model that need to be IDMP compliant. And of course, we need to have an understanding of what that means to be IDMP compliant. But that's another issue. And then if you have identified those data elements, you can link them with all the constraints about linkage to the elements in the IDMP logical model. And then you can look into the glossary that will be established to make sure that you have the right definition and you have the exact matching definition. If the cardinalities are right, if the data elements actually match the value sets, are you using the same terminology or are you using your own terminology? So if there's a mismatch, then you need to really consider the consequences, either for your design or for any translations, transformations that need to take place between the data in your system and the IDMP compliant data. And of course, if there are things missing to your knowledge in the IDMP logical model, just raise the issue with either Unicom Work Package 1 or ISO Work Group 6. And we'll try to help you out with whether you're wrong or whether we are wrong. And we'll set the things in motion to make sure that it gets fixed. So I hope I've given you an overview of the why and how of an IDMP logical model and what our main aims are. And with that, I'd like to hand over to José to go into some more of the details of the requirements and the practical use of such a logical model.
Thank you, Robert. So I'll start with where you left. So maybe should I display, or you want to move to the next slide, please? Yeah. So the fact that we are using a common logical model, or we want to use a common logical model across all these areas. So that's one of the things that we figured out in Unicom, is that the information that we have from the manufacturing side until the supply chain and until the adverse event reporting, for example, in pharmacovigilance, that has to be consistent. So of course, the normal way of doing that in IT is to set up a common model. So that's what we want to do, is to see how is this going to be enabled. So if we move to the next slide, please. The first thing that we have to consider is that, okay, where are those models and what do they contain? So trying to outline a bit the scope. So we have, let's take these examples. We have the IDMP logical model, which contains information about, or defines how the information about the substance is structured. Same thing about the pharmaceutical product, which is an abstraction created for IDMP. The same thing with the medicinal product, which, although there's many different meanings of that in IDMP, has a specific meaning. Also, it's a specific model and has a couple of other things, including those forms and rules of administration. Some of that will be used in a prescription. So in a prescription, for example, in Unicom, in a cross-border prescription or in a cross-border patient summary, we will need to define the product. And if we need to define the product, we can define the substance. We can define a pharmaceutical product. We can define a medicinal product or something else. So there will be different ways of defining a product. And this is where we are seeing the interaction between the IDMP logical model in the part that it defines a product and, for example, the prescription logical model. Also, the prescription will have treatment information, which if we define in a common grammar, in a common data structure, and with common value sets that we have, then we can maybe have a better chance at making sure that what you have in a prescription eventually will link to IDMP. So if it links to IDMP, we'll have a better chance at capturing that consistently when we are doing pharmacovigilance, and if we're seeing that if the problem is with the drug or with the dosage. But if we don't have the proper notion of, or the proper model of information behind the dosage, it's much harder to get that. Another relation between different logical models is between the IDMP product logical model and other product logical models, for example, the M&D or the SNOMED logical models, or any other national or commercial providers of product master data, where different concepts of medication will appear and that is fine. Actually, that is required because countries base their prescription rules and their supply rules and their clinical guidance on specific concepts. So some things that are, concepts that are prescribed in one country, they don't even exist in another country. For example, the VMPP is one example that exists in Diamant. It exists in many countries in the south of Europe. In some other countries, it does not exist. So, but these concepts, when they are defined, if they are defined consistently, or if I can define a medication valid for prescription in one country, and even if the other country does not take that concept, just to give an example to make it more concrete, if we say paracetamol 500 milligrams, box of 20 tablets, this is not in itself an IDMP, does not have an IDMP identifier per se, but all these attributes are IDMP compliant. So they are based on, they can be based on the IDMP grammar. So if we use that across our chain of data, then we can identify the product. So if we say that, so the substance is this one, what identifier do I use for substance, or how do I define the substance? The same thing with the strength, same thing with the dose form, same thing with the package size. So that is the interaction between the models. Maybe a few more examples will come up, but this is what we are aiming at. And the idea to link these models goes back a bit into the discussion. So let me just make a small detour to what we are discussing. Looking at the chat or the Q&A questions, we already have some difficulties in seeing what is a logical model. This is a logical model versus that is a logical model. And that's what we are talking about, requirements. If we don't know how to define something, then we gather requirements and say, if this meets these requirements, then it is a logical model. If it does not meet these requirements, it's not a logical model. So that's what we want to do. And that scope is tightly related to what we are doing here. Because if we are doing the prescription logical model for a product, that's normally very simple. It's just one identifier and maybe a couple of other attributes. If we define the logical model as it is in IDMP, that can be used for other purposes, that's much more complex. And if we take a commercial provider of the drug information in one country, then the model will be slightly different. And that's actually one of the problems that we're trying to address. For implementers, whatever information is sufficient for them to start implementing, that is considered many times the logical model. So as long as I have the information that I need, I know how to implement, so I consider that implementable. But that is implementable for my scope. And that's actually the situation that we have nowadays. So we have implementations being done in different places because we don't have yet a logical data model for IDMP. We have implementations on the regulatory side, we have implementations on the clinical side, and we have implementations on the manufacturing side and the supply chain side, and all of those diverge, or they are pretty much divergent. And that's the problem that we say we need to capture the logical model. And if we don't know what the logical model is, if we don't know the requirements, then we will just be debating what is a logical model. So that's principally one of the points in this discussion. So what does the intended logical model look like? So let's talk about requirements. They should be pretty much about the content, so what is in a logical model, and the relations. Thank you, Robert. The content is what content is inside of a data model. So we'll see in more detail. And what is really important is that we can have visual ways of representing this. So diagrams like the two things on the left that we are seeing. Maybe more structured information that is, well, the right side is also a diagram of sorts. But what matters is how we define it formally. So we can define a logical model in a technical way or in a visual way. We can store it in different ways, but what matters is that it's a formal definition. For that reason, for example, graphical diagrams of logical models, maybe some people consider it as a logical model enough to proceed, but I don't, for example, because I don't know how to map those. I don't see those things uniquely identified to map. So I cannot map a strength type, if that attribute appears, to strength type in a prescription. I don't know what those mean because they are not formally defined. So it's about defining the content and enabling relations. And as Robert was saying before, we need to establish the relations to the conceptual model or to glossary. So for example, if we know exactly what dose form means and what it does not mean, then we can keep that in a glossary. We can even have a full ontology for that, but at least a glossary, a proper and agreed definition across those 5 domains that we know that this is what we mean throughout the chain. And if we do that, then we can say, okay, this implementation, this logical model materializes that a bit. So it implements that in a more concrete level by, for example, putting the constraints and the data types and the terminologies. So we have to see the conceptual definition as one thing, the more implementable or the implementable definition, more how do you say, more structured definition of the data as the logical model. And then, of course, the link to other logical models, as I mentioned before. So for this to be so these are the requirements. For this to happen, we need to have a couple of requirements, and those are the ones that we analyze in the document. So there's a couple of them that we have the examples for. But first, the next slide, maybe a small small overview of what happens now. So the regulators and manufacturers, they have a common data dictionary. So that should be the case that everyone gets their source of truth for the things that really matter. So those form, for example, this should not be a concept that is defined with one granularity in a clinical side and with another completely different perspective in the regulatory side. This should not happen. So the regulators, the manufacturers, they already have a common data dictionary. If they have it in a logical model, in the formal logical model, that's fine. So if these elements are mapped to a common logical model, the IDMP logical model, that guarantees that when a regulator says, I'm going to add this field to our database or to our requirements, then the manufacturer knows exactly what those fields mean and how they should be produced. So that's one of the advantages of having a formal logical data model. When I say logical data model, I can also say logical model because, as Robert said in the beginning, it's not a process model, it's just a data model. So we call it for short logical model. Also, the summary of product characteristics, it is produced, but if we want to rewrite the whole information, that's creating another information model just for the SMPC, that's not really something that's convenient because that makes it much harder to maintain. So what we would want is that the summary of product characteristics is produced against a model that is mapped to the common logical model so that we have the same information or consistent information between the information that's inside the regulatory database and the summary of product characteristics, which is what we expect, and we should be enforceable and verifiable. The same thing with the medicinal product dictionaries. They have lots of attributes. Some of them should be mapped to the common logical models, and this should actually be a compliance requirement. So if we say that if in your country, if you define those form, it should be this definition. But other attributes, maybe they don't matter. So the pricing information, etc., that might not matter to be even conceptually equivalent between countries. So, and for those to happen, so when those happens, when we have a common logical model for the MPDs, then we can start talking about interoperability of MPDs. So we can talk about exchanging product data between drug databases, which at this moment is very difficult because every database, so the regulatory databases, the commercial databases, and the more clinical databases, they all have their flavors of what a product is and what a product requirements or product attributes are. And that's the problem that we have right there. The same thing with the prescriptions and dispenses and ICSR. So if we include the product definitions, so if we have to say, this is the prescription, I have a code, and this is actually the Unicom example. If we have a code, but I know that the code is not going to be understood in your country, then here's a few attributes that should be enough for you to understand. And of course, in that case, I would like to use the IDMP grammar, so the IDMP way of describing those attributes. I don't want to write in text in Greek, for example, that this is paracetamol 500 milligrams tablets box of 20, and then hoping that someone in Finland would actually understand the same thing. So that's what we want, is to have that common grammar. And the supply chain, of course, the same attributes. And for this to happen, it's not only up to the developer's intuition to say, or best effort to say, yeah, my model aligns with IDMP. This should be a formal mapping and a formal verifiable mapping. And that's why we need a formal structured IDMP model. So Robert, if we make to the next slide, please. So the logical models are and should be always input to physical layer specifications. They capture the constraints. So if we want to say, for example, that this attribute has a specific technical format, that really doesn't matter functionally. But if you want to say that functionally, no, those form, this is the vocabulary. So I'm kind of implicitly answering part, at least the question that was asked by a colleague there. What's the overlap or some overlap between this and the SPOR effort? That's exactly the point. So SPOR says these are the rules for the data, but it does not define one model that puts those things together and is mappable and is formal and is structured. So that's, we want to capture in the logical model of IDMP any such requirement. So if there's a requirement in Europe, for example, that says this is the value set that you shall use for those form, if that happens, then this is functional. This has a functional impact, has a legal impact. So it should be captured in the logical model, not left to the best effort to the physical implementers. And that's why the design should start from a logical model whenever possible. And that is one of the issues that we are having nowadays. We did not have this. We did not know whether we have this. So there's some disagreement whether our model is fine or our model is insufficient or our model is incomplete, because we did not have the requirements. And since we did not have the requirements, we did not know where were the gaps. And that's why we have today so many challenges in advancing, because as everywhere, what happens is that if the formal definition of the model is not there, then people will just go ahead and do their best effort to implement things. The problem is that people in different countries and different organizations will have different interpretations if they are not frozen and solidified in a formal and structured way. And the other consequence of this is that if we have formal and computable models, so if we have structured information, for example, if we say this is the data element, this is the definition, and this is the cardinality, and this is the data type, if we have this in a computable fashion, then it's not a matter of looking at documents and interpreting those documents. It's actually a matter of telling the computer to say, I want to see if my logical data model or if my implementation is consistent with the other implementation. This is something that we are using. So there's a couple of implementations that I'm pushing also to put logical models, not in the product area, but in other areas. The fact that we have a central logical model, it makes it very easy to say, are we diverging from the model? Can we say this without going through all the interpretations and all discussions again? We don't have to. So formal and computable models can be used in validation. If I make my change to the model, then I want to see the impact. If I change my implementation, I want to see if I'm diverging from the impact, and that will be impacting all the implementers there. And the next slide, please, Robert. Yeah. So the content, so the more detailed requirements are in the document, but what we reached is that the logical model contains data elements and additional metadata about the model, the logical model itself. So things like each data element or the logical model, they have to be uniquely identifiable. And this is one simple requirement that it seems obvious, but if it's not formalized, then we don't know how to map. So if I know exactly what those form means, or if I think I know exactly what it means, but if I don't have a unique identifier for that data element, then how can I make sure that my mapping is going to feed into the IMA mapping or into the SPL mapping? So how does that work? It does not work. So we need to have data elements uniquely identifiable. Metadata such as status, last time or date that it was updated, the descriptions, who owns this, etc. Those are metadata that we always need to see. Am I using the right model? Am I not using the right model? Is the model different? Is this thing approved, or am I working on still some dynamic model as we have in many places? The other thing that we need to identify is terminology constraints when they are meaningful. As I said before, if something is really supposed to be bound to a specific terminology because it's my technical choice, then it doesn't need to be on a logical model for IDMP. But if something is really mandatory to be like those forms, if we have a reference vocabulary for those forms, and if we want to establish those form common vocabulary, then that should be reflected in the logical model. So we should see whenever you use those forms, that is the vocabulary that you shall use. Same thing with the dependencies. So if we say this element is only present if that other element is present, or this one is not present if the other one is present, then that should be something, again, structured and computable and captured in the logical model itself. And then the maps, that's something that we will always have, because if we have the identifiers, we'll always need to have mappings. And one key point is that at least for the key elements, we should map to the concepts. So we don't have to have a glossary of everything and an ontology of the universe. We don't. As long as we know that these critical data elements, as we call them, the critical data elements for the product model, if they are correctly defined, then we are safe. We don't need to define what this pricing schema means, because that's most likely not achievable. But if we know that dose form or strength type, if we know exactly what that means, and if that is in a glossary, we don't want the logical model to deviate from the glossary, the same way that we don't want our implementations to diverge from the logical model. And that's the cascading that Robert was showing before, and that's extremely important to have a formal model. If we don't have it, all that cascading becomes an interpretation. But if we do have it, we can verify if my definition is consistent with the definition in another country or in another kind of institution, if my terminology is consistent or not with the other terminology. That's why we need those mappings to be in place. There are other things about mapping to concepts, but that's for our scope where we don't have problems like privacy and data classification. That's not really important. But linking to concepts is also important on that area when we go more into data management. So the formats, once we saw these are the main requirements, so these kind of requirements, that's what we want. We developed them a bit in the document. Sorry for this. When we have those requirements, we also said, this is what it should have, but how should it be represented? Okay, we have to see what is the format of capturing this and what are the tools to capture this. So the format, the requirements, we said in the requirement that it shall be mappable, it shall be computable, and it should be open. So mappable because we need the mapping. So if we have something that's not mappable and computable, for example, if we have something that's just a diagram, that does not make it mappable or computable. The computer cannot, well, nowadays computers can do everything, but we cannot really expect reliable mapping or easy mapping if something is not defined in a technical format or with a technical substrate. If it's just a visual representation, that depends on humans to understand it. For this, there is a reference standard, ISO 11179, that defines metadata standard. That's really, really technical and really, really abstract or meta, but it does provide some of those requirements that a logical model contains data elements, and these data elements should contain that metadata. So that there are standards for that. There are many other standards, including also more in healthcare. But the way to define these things actually influenced the way that we have been doing this in several projects in FHIR. And I want to draw the attention to what we did what the communities did. I was not, unfortunately, in that effort. I only appreciated it. The International Patient Summary. So the International Patient Summary, they also felt the need to define the logical model. They wanted to go to a concrete implementation in a given standard, but they wisely gave some first step, which is, let's see what we mean about the data. Let's capture this as a logical data model, because otherwise we are just going to be debate standards that are going to be used in different ways. And that allowed, for example, that they did not have so much problems as we are having now with FHIR, with mapping things with different resources, because they start with a logical model. So if they did that, then they could easily say, this is what we mean. How it gets implemented in one standard or the other, that's something that we can manage. We can have the same model implemented in 5 different standards because we know the model. If we don't, if we let the standards emerge as scattered here and there, then we advance faster, but we have the risk of eventually finding some inconsistencies, which is why we need this work as soon as possible. As someone complained that this should be already there, and it's not. So sadly, that's not the case that it's there, but we are working to make this as fast as possible. So FHIR provides a standard open mechanism to provide this metadata. So there is FHIR as a standard. Although FHIR is a technical standard, it also allows us to define non-technical data. So there is a way to do this in FHIR standard. That's the one diagram that I showed before, the one on the right. The UML provides a visual representation of data. It is somewhat computable, but the UML standardizes the visual part of it. So the arrows and the entities, etc. And there are proprietary solutions that combine them both. Enterprise Architect, Visual Paradigm, for those that are more used to modeling data, this is what we use, those kind of solutions, because we can see the visual side of it and the computable side of it stays always under the surface. And that's very powerful, and that's something that we need. And so we have different types of solutions, and the mapping, of course, is even less standardizing. So how to do the mapping between different models, that's even less standardized. So we have we had also to capture some requirements about the tooling for this. Robert, if you don't mind moving to the next slide, please. Yeah, so we looked at the tools, and we also looked, logical model is not going to be something that appears overnight and then is frozen forever. It will have a life cycle, and it's not going to be one logical model. As we've seen, we have different logical models: the prescription, the manufacturing, the supply chain. All those things have their own logical data models that are parts, sections of one truth that we don't want to model. But if I need to know exactly what I have in the supply chain, even if that only partially overlaps with IDMP, but I need to have that model. Each of those models have a life cycle. So, and those life cycles will be different. The life cycle for regulators will be different from the life cycle of prescriptions, and life cycle of prescriptions in one country will be different from the life cycle in another country. Sometimes some people will want to make more increments to their logical model than others. And that is why logical models must be interoperable. So if I want to keep those models growing in parallel tracks, but somehow communicating and seeing, am I still compatible with the main model or not? Is my national model consistent with the EMA model? If we want that to happen, they have to be interoperable. And that means the structure and computable and open that we had in the previous slide. The timelines for this. Well, we have today, what I just mentioned is that we have an implicit or an explicit model, but there is divergence and it is growing. So that's one of our current challenges, is that the longer we wait until we produce something and we formally produce something and we make it computable and mappable and verifiable, and we say this model is not correct according to that model, the longer we wait, then the further the divergence will grow. That's what we have today. Different implementations, different standards, different physical representations of the data, they are appearing. And then at the end, we'll have the same problem, which is someone is reporting that maybe there's a problem with overdosage of one drug, but well, we don't know how to identify. We don't even know how to identify dosage. So then we cannot do anything. So we are losing time, and we are losing the opportunity as well to do good with this data if we have a common consistent model. So each organization will manage their things their way. So we don't want to have one dictator model that says this is everything that you have to know. We want to say this is the core that you need if you want to be compatible with others, with these others. And then we send the same message to everyone. That's why ISO has a role. That's why Unicom does not say this. ISO has to say this, and ISO has to be, because ISO is the place, the institution that has to be considerate of all the possible divergences, all the possible things. It's not an imposition, it's a collaboration effort, and it's according to the review process of ISO that will have different feedback from everyone, and eventually we will agree on something that, okay, this is something that we can propose as the standard logical model. And this is what I wanted to explain. So I wanted just to summarize a bit. During the work that we've done, we explored the logical models, what they would be used. So the scope is extremely important. The way that we use models, that we capture models, is very important as well. So what tools do we use and what is a data model? And if we did not have those requirements, today we will still be discussing, in this time that we spent, we'll still be discussing, this is a logical model, no, this is a logical model. And that's exactly why we need those requirements to be clear. And that's it from my side. Robert, you want to take over?
Yes, thank you. And in the interest of time, I'll just do a very quick wrap up. And as you said, a lot of time has been spent on what is the logical model and what do we want it to do and want it to solve. And this also links into a comment in the Q&A. If we needed to do something, we need to add things, and that's exactly what our requirements are trying to do, to put forward what do we need in order to move forward. And of course, there will not be one logical model for all purposes and countries. It's about the key elements or the critical elements or whatever you want to call them that need to be shared across the domains. And I think the main takeaway from José's part is really that if we do not have a formalized or computable representation, everything will depend on human work and the minds of people. And they become overloaded. So if we have a formalized and computable representation, at least part of that work can be automated, and a lot of the validation and mapping can be done in or can be supported by the proper tools to make it easier to understand whether your implementation is actually compatible and validated against the logical model. So with that, I'll hand back to our moderators.
Thank you, Robert. So we walked through this exercise together, and the two presenters are thanked for their efforts to explain, and also sometimes to get inspired by the chat box and the Q&A, sorry, so that they could already give their feeling on some question. During the presentations also, we had a number of questions or comments in the Q&A. I would like also here to thank the panelists because some of them provided either an answer or a comment on that. So please continue to use the Q&A facility so that we can now start with some questions. I think the panelists can put their camera on so that everybody sees them easily. One question is about ICSR. I read the question. Could you please explain how the logical model will help with the ICSR? The ICSR mainly use identifiers resulting from IDMP implementation. Furthermore, some ICSR data elements it's jumped a bit on my screen. Furthermore, some ICSR data elements referring to IDMP will just reflect what the reporter or the patient or the professional has stated, and this is not necessarily matching what is captured in the product database. So eardrops are administered to the eye, product are being used for unlicensed indication, etc. So in summary, could you please explain how the logical model, the one we are talking here about, will help with ICSR? Who would like to answer that?
Well, this is Lise. José. I guess since I did ICSR, I can probably at least start. So when you think about ICSR, you have to kind of think about two parts of the reporting audience, right? So for pharmacovigilance that is performed by industry and regulators, the specification that they implemented is referred to ICH-E2B R3. That's the part 2 of the ISO specification for ICSR. The intent was that we was hoping that by this time, those identifiers would be available for use. And the idea during that particular time was that for regions, because remember, manufacturers had to submit reports about their products in all the regions where it's licensed. And sometimes the reporter that may not know exactly what the manufacturer product is, meaning they may not have the product identifier or the NPID that's defined. And so what the regulators as well as industry have to do is look at the information that's currently in their database and try to make associations in terms of what are the products that are actually licensed in their region and how that actually maps to a foreign product. So on the regulator side, the whole purpose for the identifiers, I'll just say it that way, in terms of the identifiers themselves, that was really part of what the pharmacovigilance use case was about. Now on the healthcare side, which I think is where things have evolved since this work began, there's more interest in that part of the reporting. But again, it kind of really still boils down to some of the core data that is available about the product itself, whether it's the generic name or a brand name, independent of the identifiers, because again, depending on who's doing the reporting, they may or may not have some of these other information that's available to them. So I think the logical model from the standpoint, I think from the pharmacovigilance side of it, because they're using a different logical model, okay? So there will be, I would say, repurposing or trying to align with the information in the pharmacy domain. But in ICSR, it's really more heavily clinical, okay? Because you have to make that causality assessment between the exposure and when the symptoms occurred, all of these kinds of activities. So the idea is to try to make sure that things are consistent, but remember, ICSR, what they share in common between IDMP and ICSR is the drug information section, but a lot of the clinical pieces in IDMP, for example, the clinical particular section, right? That's where a lot of that clinical data is represented or coded, but it's not at the level of detail that an ICSR would capture or need to consider for pharmacovigilance purposes. So I hope that answers the question.
Thank you, Lise. José has raised the hand.
Just one example for that really helped me understand. So I don't have a clinical background, but this really helped me. So taking the example that Anya has expressed, that's actually one good example of different logical models. So you have in the product model, you have the indication of the product. Oh, sorry, in this case, the route of administration. In another system like the ICSR, you have the route of administration, but they are not the same data element. One is the route of administration that is authorized for the product, the other one, or that is recommended for the product, and the other one is the actual route of administration that the patient has taken or will take. So that's, in some cases, that will make it an off-label use, etc. And if we say that, so if we don't have those two things as clearly different data elements that have a clearly different definition, if we just rely on the name, then it seems simple, but since we don't know, we are not mapping it to a common logical model, we will never figure out that, wait, I'm just putting a product indication, but is it really the same thing? If we have a proper definition, say, no, this is the one. So in the IDMP logical model, we say, this is the route of administration for the product as it is recommended by the manufacturer, not in a clinical use. If you see that, then you will not use that data element. Then you will understand that you will accept that there will be difference between the actual indication route or the route of the administration between the model in ICSR and the route of the product, the route of administration of the product in IDMP logical model. I hope that example helps somewhat.
Thank you, José. Do we have another question? I'm looking in my Q&A. I have no new question. Maybe somebody would like to add comments to what has already been said between this interaction, the global or the ISO IDMP logical model, and as an example, the ICSR one. Can I give you the floor, perhaps, Julie, because it's a bit your field of activities, I would say.
I've tried a little bit not to jump into this one. I am not, like Anya, I am not terribly sure how the IDMP logical model would affect ICSR other than what's already been said, because as Anya says, the ICSR uses the identifiers. Yes, it's very important to know what you're identifying and where that's come from within the business process. But the ICSR is fairly clear about that, and IDMP is fairly clear about that. I think where these additional models come in are when we're looking at a particular business process that is almost entirely covered by the IDMP standards, such as the granting of a marketing authorization. That's the sort of business process where looking at the conceptual model, you need, which very clearly in the ISO standards says we're centering on the medicinal product. That's in a sense the starting point, the point at which you serialize from. But if you're going to do something like an application process, you're going to be starting from a different point in that overall model. You're going to be starting from where the application exists, and it might relate to one or many PCIDs or one or many MPIDs, and this is more where these types of intermediate models come in supporting the different business processes. Whereas for ICSR, it's got its clear business process and an awful lot of guidance already around it.
Thank you, Julie. I have some further comments. The first, because I saw that Noel wants to say something regarding now the timing, because it's quite crucial. Not only we have this global approach, but also it's a question of timing. Noel.
Yes, so I've read quite a few comments on the topics that I have been discussing in the past as well. The main one is the timing. Right now, we are in a place where we like to implement IDMP. So from an EMA side, we have this huge thing which is mandated across Europe, which is the implementation guide. FIRE is going one version after another in trying to define the relations between, well, not only the relations, but the relations, the cardinality, the types. So all that kind of make parts of a logical model. They're defining this right now, and we are starting to implement this. So within the next 2 years, a lot will be created. And this is a lot of software as well, which is, I mean, money is not the most important thing here. Most important thing is to have clarity and not confuse people. But it is going to be an issue. So in 2 years' time, we will have a lot of software in place already based on, in Europe at least, based on FIRE, based on the IG from EMA. And this means when a new model comes in 2 years' time, maybe 2.5 years' time, when this new logical model is there, it needs to incorporate all of these existing relations, all of the existing cardinalities. José mentioned dose form as an example. We already have kind of a rule that we know that there are 4 different lists. There are in RMS. Now, of course, this is only Europe. And I'm only talking about Europe here because this is our main thing. I understand that the LDM is going to be global, of course. But for Europe, at least, it could potentially disrupt if the new model is not following the existing approach. Thank you, Julie.
Yes, thank you, Noel. I completely understand about the issues of timing, and that's frustrating. I think when we go to with the things that you're talking about, which are the actual physical implementations, it's, yes, FIRE is a communication technology, but it's still a very physical technology. And then you're building all of the software around it. We're down into the actual physicality of the things. So we've jumped directly from this conceptual model right down to the physical. And we've missed out some of the steps that we would normally go through in the development process, particularly when we're trying to interoperate. If we're not trying to interoperate, those intermediate steps really are quite an expensive effort. But when we're trying to interoperate, and we're trying to interoperate around a range of business processes, and I know that the EMA is focusing on one particular business process, which is getting data in, whereas José in particular has been talking, well, both José and Robert have been talking about a range of business processes. We are in danger. And as you say, if something comes in 2 years' time, and you have to look backwards, it's an issue. I personally would prefer to go through the steps a little more logically, hence logical data model, although I'm not wedded to that name. It's a discussion we have internally here in the family, sadly. But I see the pressure of time, and it rather does feel like we're trying to square a circle. but I'm a bit worried that if we don't take a little bit of time to look at that, and we are rushed or pushed into a very physical implementation, particularly in here in Europe, we carry with it some risks. If we understand those risks, that's actually 50% of the battle. So that's part of that this discussion as well.
Thank you. I think Jeff Martin has also raised the hand, and he might speak a bit in the same context.
Yes, I have a number of comments. I've talked a lot with Julie and a little bit with Noel, and I think we are reasonably in agreement as to what the position is, but the the problem we have is this timing that Noel talks about, which is really important because we're already very late with implementation of this compared to the legislation that we have and the pressures that we have, and that means that we really cannot wait for the logical model. So what we're going to have to do is produce the logical model at the same time as we implement the FIRE model, which I know isn't the way it's supposed to be done, but we really don't have any choice about that right now. And that means that we're going to have to be very careful to make sure that things are consistent. In the EU implementation guide, which I've worked a bit on, we've had to do some extensions because as we've tried to do implementing, we've found problems with IDMP as it's written now. There are places where it is not very clear, so we've had to make some decisions. Places where things are missing. Things where some things that are probably buried in SPL, which, you know, people in Europe don't understand SPL, don't know SPL, and since the ISO implementation guide is what's the word I'm looking for? I know I'd used it myself in an answer. It is yes. Sorry.
I'm sorry. This is Lisa.
Prescriptive. Yes.
References SPL. Yeah.
Prescriptive. Yes. Thank you. Thanks. But it's buried in there, and some of the things that are supposedly prescriptive are not mentioned in the standard whatsoever, neither in implementation guide or in the standard, but because it's part of SPL, then it's there. Then it's in principle supposed to be there, and it makes it really, really difficult to implement. And one of the comments that we've had in the Q&A is how difficult it's been because the standards are fuzzy in places. So that's one point I wanted to make. Another point I want to make is José and Robert have been talking about several models, and I think we have to be really careful there because we have at the core, we have a product with a name and a form and a strength and a bunch of ingredients and maybe some packaging. And that stuff has to be the same in the different models. If we start changing those definitions for different use cases, then we're going to be in really deep trouble. So the model, but you're certainly going to use different parts of the model, of a bigger model, for prescriptions or for regulatory or for adverse reactions. But a lot of the core has to be the same. Otherwise, we're in really deep trouble. And the other one I wanted to bring up was what Anya was talking about, this bit with identifiers. And in ICSRs, you're supposed to use the identifiers. One of the big problems that we've had in the implementation, at least from the perspective of an NCA, a regulatory agency, is these identifiers are shaky. The definitions in the standards, if we start with the MPID, for example, that it is, it's not clear exactly the life cycle. How does the life cycle of the MPID change as the product life cycle changes? And it's never been clear to us, and nobody's ever been able to explain to me and some of my colleagues exactly how that life cycle that we sort of get from the standard, how that is useful for ICSRs and adverse reaction work. And I don't think we shouldn't go into that now, but just this is the problems that we've had. So for example, because the MPID is not stable in principle over time, in PMS we have introduced a PMS ID that is stable over time. As soon as the product is saved in PMS, it's going to get an identifier and it's going to live with it forever. Because that's the only way we can keep a history of the product, because as the MPID changes, you have to know what's going to happen. And I don't want to get more into that right now, but this is just some of the problems that we've had because of the identifiers being unclear. And I think a lot of this relates to back to that the standards are quite theoretical, and we're missing really good, well worked out examples, and lots of examples. The little fragments of examples in the implementation guide, a lot of them are quite trivial examples that don't really push the standard. So it's as we've been working on examples that we found some of the issues.
I think,
and we haven't found all of them yet by any means, I'm sure.
Certainly not. Jeff, thank you for your comments, but I have to say that the IDMP standards have been triggered by ICH, and this is including the national competent authorities and their overarching bodies such as the European Medicine Agency. So, I mean, it has not been written by people who are not subject matter experts.
In Europe, it was basically the EMA for the product, and none of the NCAs were involved in that. And that's no, Kristen, wait a second. I've heard this from you before. The point is that it was done between the EMA and the FDA, and those are the two bodies that wrote it in practice. And yeah, no, that's the way it is.
But that's not the topic we are talking here about.
No, I know, but I'm just saying that that's part of the problem has been that that the knowledge has been very small and very theoretical, and not broadly based, not on a broad consensus. Okay, I'll stop now.
Well, I think this is inappropriate as a statement here, because we are talking here about the requirements for an IDMP logical model. And now we have an involvement of subject matter experts such as you and many others to express the requirements. And suppose it is not theoretical. We are going now to end this session in a very short time, but the last speaker will be José, and then I will conclude with a few nicer words.
Thank you, Christian. Just so I would take the opportunity that Jeff just gave to explain one of the things that we want. So I think in the role of this group, we are all taking a constructive and supportive position. So we want to say, we need to help you, but to help you, we have to do something so that the others will also benefit, because we want to link all these things. So a couple of things. What you said, Jeff, is very right. We will have different parts of the model in different places, but it doesn't mean that they are going to be incompatible. What we want to do is to say, how can those differences in processes, in requirements, how can they be met with the same common model? And that's I think what you were aiming at, or what you expressed your wish for, and that's exactly what we want. We don't want one model that is thrown at everyone else and everyone else has to swallow it. We want one common grammar, one common definition that different processes can reuse part of it. And that's what we want. We don't want an imposing model. We want a supporting set of attributes and identifiers that we can use. Yeah, the part that you mentioned about the processes and how IDMP relates, that's indeed a bigger discussion. I fully agree with you that there should be more examples and more concrete examples of what we are doing. That should have been in the beginning. And finally, just one comment, but that's part of our approach that we have. We have taken the risk when doing implementation. So if we take an implementation based on something that there is no model yet, we are taking some risk. What we cannot do is to say from now on, we don't take any risks. What we will do, everyone, I think all the participants in this thing, from manufacturers to regulators to the SDOs to everyone, is to say we had to do something. We knew that this contained some risks, so now we are going to take some of the risks. So if we have some changes, for example, in the fire resources that I expect we need to have if we want to link the IDMP model across those areas, if we have those changes, then that is part of the risk. The work that is being done now is to propose some of those changes, not with any risk, not without any risk, because fire resources are currently in maturity level 1. So we expect some changes. We need some changes, but those changes will not appear because one person has an idea from the other. They will appear from implementing and seeing where this works and where it doesn't work. So in that case, we took some risks, and the work that we are doing is to how do we move forward, minimizing those risks. Believe me, there has been a lot of work and lots of discussions in how can we improve the existing standards, minimizing the risks. But the fact that we did not have the model up front, like in every system, if we don't have the requirements clear up front, then we should do something. We cannot stop, but that does not mean that later we will go and change the requirements or change the model just because we have already something implemented. We have to take part of the risk, and that's what we want. Everyone has to be on that level. So ISO will have to accept the risks of maybe adjusting something and clarifying something that should be clear. We have to see how the regulators and supply chain have to support some of that risk as well. And of course, whoever goes ahead has more headwind and has more risks. So they have maybe to accommodate for more of that. I don't see a big drama about these things. I just think that we should be clear that we took a step, we knew the risks, but now we should accommodate for that, and then we just move on. Things are simpler than they seem, and once we see the models appearing, then we'll see that it all makes sense together. That's my impression and my wish.
Thank you, José. We are aware that ISO is not somewhere an angel in the skies. ISO is made of people like you in the audience. Nothing happens if the experts, don't contribute, and if the experts say we should go faster or slower, that evolution will happen at that speed you decide. We will see if the ISO logical model will come up fast or not so fast. It will depend on the expert engagements. We have now an outstanding team which is in building until the end of the ballot, and I'm sure with your contributions we will be well positioned on one hand to take into account the existing European implementation guide, the existing experience, the identified gaps, which will, that's normal, occur and pop up along implementation. But what I was a bit in disagreement is to say that was all theoretical. I mean, I met these people along, and I wouldn't say they are theorists. There are people with some practice and very in-depth knowledge, and that deserves respect. It's perhaps not exactly what people expect today, but we have to respect those who dedicated such an effort to develop the IDMP standards. Now, we are coming to the end of this Committee of Expertise. I would like to inform you already that the next one will take place on it will be a Tuesday, the 23rd of March. It will be at 2 o'clock Central European Time, so a little bit different to today. And the topic will be the European Implementation Guide. We will have 2 speakers from the European Medicine Agency. It will be highly interesting, I know, because it is not disconnected to today's discussion. It is exactly in line with today's discussion, and it will be sharing again experience, sharing knowledge, and integrating that. I know that those who will be working on the ISO IDMP logical model will certainly join that call also to hear and possibly ask questions and get answers on aspects which will impact their work. So with this, I mean, we are really in a very, very important and living situation. And I'm grateful that we had the speakers today and the panelists. I'm also grateful for the panelists to have answered a number of questions or remarks which were written in the Q&A box and which we wouldn't have had time to answer now live. You have still on the screen the questionnaire to see if you were happy or not happy about today's discussion. It is for us kind of a thermometer to understand what is the feeling of the audience about what we shared today with you. Again, the purpose of a community of expertise is not frontal discussion. You have seen from the panel also, we have critical point of view, and it's absolutely in the sense of what we want. We are open to discussions. And even the critics are welcomed when they are not so personal. And I think this is helpful to make the progress in the implementation of IDMP in the context of Unicom for Europe, but also having the rest of the world in mind, because the rest of the world will also benefit of our experience here in Europe. Well, at this sense, I'm going to close this Committee of Expertise for today. We look forward to meet you in a few weeks for the next one, and wish you an excellent weekend, hopefully sunny like it is by me, healthy for you all, and I look forward to meet you bilaterally or in a screen in the very next time. Good afternoon, and thank you again.
Thank you. Bye.
Thank you all. Bye-bye.
We are not so many on the screen right now. And I suppose everybody has seen the result of the questionnaire. tough discussion at the end, huh? I must say. Well, we are.
We're just us.
Yeah, but I had individually to.
Are we still on YouTube?
Sorry?
Are we
We
still?
have to stop the recording, I think.
Oh, yes, I could stop the recording. All right. Thank you.